Here's a typical GCSE level circle theorem question. C, D, and E are points on a circumference of a circle. There are points C, D, and E. Angle A is 100 degrees. This is the angle. Work out the size of angle B. If you're familiar with circle theorem rules, you will know that the angle B is 50 degrees. It follows this theorem, which says the center angle, which is A, is double the edge angle. So, because A is 100, it's double the edge angle B, which is 50 degrees. But why are we so certain that the center angle is double the edge angle? Well, that's what we're going to be showing in this video. Let's take a brief look at how this shape is constructed. We have the center of the circle, and from the center, two lines go out in different directions and end at the edge of the circle, the circumference. The lines going in different directions creates an angle. Then there is another point on the circumference, which is not the center and not the end of the two original lines. And from that point, two more lines go out, each of which go to the end of one of the original lines and joins it at the circumference. So we get this overall shape. Notice that because the first two lines go from the center to the edge, they are the length of a radius, so these two are the same length, but there's no guarantee that the other two lines are the same length. In fact, you could have this situation where the same thing happens, but you can clearly see that this length is shorter than this length, and the two longer lengths, the outside lengths, don't necessarily have to be outside of this angle, because you can have this situation where one of the lengths is even inside the original angle, but the same rule applies. We won't be proving this one today because it's slightly more complicated to prove it, but the rule stands. A is twice the size of B. So now let's go about showing that the angle A is double the size of the angle B. First thing I'm going to do is get rid of that B because we don't need it there at the moment. We'll come back to it later. Then I'm going to draw a line from the center of the circle to the circumference right at the origin point of the angle B. And what that does is it creates two new triangles. And notice that because this line goes from the center to the edge, it's also the same length of a radius. So we've got three lines, three edges that are exactly the same length. Now I'm going to create a third triangle by drawing a line to join the two end points of the original lines at the circumference. So now we have three triangles. If we look at the bottom triangle, you should immediately see that this is an isosceles triangle because these two edges are the same length, and when you have a triangle with two edges that are the same length, it's an isosceles triangle. So let's add the markers in. And because this line is the same length as the other two, that means that this triangle has two edges that are the same. So this is an isosceles triangle. And this triangle has two edges that are the same. So this is also an isosceles triangle. So let's mark that. Now let's add in the angles at the bottom. And as we all know, that the base angles of an equilateral triangle are equal. So let's give each of these triangles equivalent base angles. These are the base angles for the bottom triangle, and then the base angles for the left triangle, and then the base angles for the right triangle. Now that we have all of the angles labeled, hopefully you should be able to see that these three isosceles triangles actually make up one larger triangle, where the size of each of the angles in the larger triangle are made up of the base angles of the isosceles triangles. So the size of the top angle is E plus D, the size of the right hand angle is C plus D, and the size of the left hand angle is C plus E. And given that the sum of angles in a triangle is 180 degrees, then the sum of these must be 180 degrees. So we can write an equation to reflect that. So we get that 180 degrees equals, well, we have 2C, two C's in the bottom triangle, plus then we have 2D 2D plus 2E's. So 180 degrees equals 2C plus 2D plus 2E. But also notice we could find A in terms of the other angles in the bottom triangle, because some of the angles must be 180 degrees, and that must be equal to A plus 2C. And what I'm going to do now is convert this to C using this equation. If we simply subtract A from both sides, 180 degrees minus A equals 2C. Then we can make a substitution using this value into this equation. So if we rewrite that, we get 180 degrees. We're rewriting the top one, remember, equals 2C. Well, 2C is 180 minus A plus 2D plus 2E. Because we're trying to compare A with this angle up here, let's get A on its own. And in order to do that, we need to add A to both sides, because adding A here will make it disappear and we'll get it on that side. So 180 degrees plus A equals 180 degrees plus 2D plus 2E. Now notice on both sides of the equation you have two exact elements, or two elements that are exactly the same. You have this and this. So if this is the same as this, then it must mean whatever's left, this must be the same as this. And we have that A must be equal to 2D plus 2E. Now we're running out of space, so let's go over this side to complete the equation. Notice that on the right hand side, both of the elements are a multiple of 2, so we can factor out 2 on the right hand side. So A equals 2 times, I'm going to swap it around, it doesn't matter which way you have the values, E plus D. Now that means that A is 2 times the size of E plus D. But what is E plus D? Well, E plus D is the angle at the edge, the top angle. So A is 2 times the top angle. The top angle originally was B, which means that A equals 2B, or the angle at center is double the angle at the edge. And in that way, we've shown why the theorem works.